Great, so we are starting a new chapter. We are starting chapter 5. We are going out of order in chapter 5 because lessons 1 and 2 are on graphing and they're kind of difficult. And I think if you know how to do factoring and then you do graphing, it makes more sense. So what we're going to do today is just straight vocab. So it's a shortened period, we are just looking at vocab, and your homework is a vocab quizzes. So it is all vocab, all day. And then tomorrow we will start with factoring. And you already kind of know how to factor. So tomorrow will be that. Let's see if this works.
Is that what was on the packet that Miss Ward gave us?
So you would like to get ready for chapter 5. So you had like some things that went with this. Like you had the shapes of the graphs of the quadratics. And I asked you to find the vertex. We're going to talk today like, what is the vertex? How do we find the vertex? What does it represent? So a quadratic function is different from a linear function. Up to this point, we have been focusing our study on lines. So up to this point, we have been focusing on lines. Probably going to go back here so the computer can hear me better. So we have been focusing on graphing lines, finding their slope, and finding their intercept. If you recall, the y-intercept for a line was where it crossed the y-axis when the x value was 0. In this chapter, we are going to study second-degree polynomial functions. These functions have a special name. They are quadratics. Their graphs will form a parabola. So we're going to look at the graph of a quadratic today. And we're going to look at the shape of it. A quadratic function must have degree 2. A quadratic function is a polynomial with degree 2. The a value can never be 0. We will look at two different forms of the equation. We'll look at standard form and vertex form. Just like when we had lines, we had different forms for lines. We had point slope form. We had slope intercept. So with a quadratic, we have standard and vertex. So again, very similar to lines where we have different forms. A parabola is the shape of a quadratic. A parabola is the shape of a quadratic. We describe it as U-shaped because it kind of looks like the letter U. So there are very few characteristics that we know about for quadratics. So we're going to learn all about them today. A quadratic is in the form ax squared plus bx plus c. The leading coefficient a is positive when the graph opens up. So this graph right here has a positive a value because the graph is open up. If the a value is negative, the graph opens down. The vertex is the highest or lowest point on the graph. The vertex is the highest or lowest point. So the vertex is the highest or lowest point on the graph of a quadratic. It is always represented as an ordered pair. It is always represented as an ordered pair. And in the case of this graph right here, this point would be the vertex. If we are in vertex form, it's h comma k. But again, this point right here would represent my vertex. All quadratics will have a max or a min. They will never have both. A quadratic will either have a max or a min. The max or min will always occur at the vertex. The max or min will always occur at the vertex. A quadratic has a max if the a value is negative and the graph is open down. So right here, this graph on the right side has a max because the parabola is open down and the a value is negative. A quadratic will have a minimum if the a value is positive and the graph opens up. So a max will look like a U-shaped graph open down, where the a value is negative, and a minimum will have a graph where it is open up, and the a value is positive. So open down like a frown, open up like a smile. If you're happy, you're positive. If you're negative, you're frowning or angry. The AOS for short, or axis of symmetry, is the line that cuts the graph of a quadratic function into two mirror images. Its equation will either be x equals h or x equals negative b divided by 2a, depending if we are in vertex or standard. And again, this will make more sense as we get into the lessons, but this is a good little cheat sheet for all the vocab and important information for this whole chapter. Vertex form is the equation y equals a x minus h squared plus k. F of x and y are the same thing. This is function notation. The vertex in vertex form is h comma k, kind of like in the absolute value. The vertex was h and k inside the absolute value. Vertex form is nice because you can see the vertex. There are transformations of quadratics. A quadratic function may be shifted in many ways. The a value will determine if the graph opens up or down. That will also determine if I have a max or a min. It will also determine, much like an absolute value, if the graph is stretched or compressed. The rules are identical. If it's between 0 and 1, it's compressed. If it's greater than 1, it is stretched. So the rules for the A value in stretching and compressing for quadratics is the same as they were for absolute values. The vertex tells us the translations of the quadratic function. The h value tells us our movement left or right. The k value tells me my movement up or down. A vertex of 0, 0 represents no shifts and gives the parent quadratic function.
So is this kind of like the absolute value graphs that we were doing?
Yes, it's very similar in terms of like the movement left, right, up, down, etc. Except for absolute values for like a perfect V. These are going to be a little bit more U-shaped, so the tables are a little bit trickier because it's not linear. So it's not like up 1, right 1, up 1, right 1. It goes like up 1, right 1, up 4, right 2, up 9, right 3. The slopes are different. So y equals x squared, that's the parent quadratic. That means it has no translations or transformations. So y equals x squared is known as the parent quadratic function. Y equals ax squared plus bx plus c is standard form. This one is more convenient for factoring. Once again, the a value cannot be 0, and the c value is kind of like the b value in linear. This represents the y-intercept. So the c value in standard form is the y-intercept. So why do we look at quadratics? We look at quadratics because parabolas occur in many real-life applications, especially those involving satellites, flashlights, roller coasters, etc. Okay? At either doing the period 4 or period 9 quizzes, depending on your class, obviously. If you're period 4, you'll click that link. Period 9 would click that link. So you want to do that. It is due before class starts tomorrow.